Welcome back to our learning session. Today we'll be discussing about homework number 5. There are around 13 questions in this homework. We'll be going through each of them. Let's deal with question number 1. Manufacturer receives a shipment of 100 parts from a vendor. The shipment will be unacceptable if more than 5 of the parts are defective. The manufacturer is going to randomly select parts from the shipment for inspection, and the shipment will be accepted if no defective parts are found in the sample. How large does K has to be to ensure that probability that manufacturer accepts an unacceptable shipment less than 10%? How do we do this? This seems like the problem of hypogeometric regression or hypergeometric distribution, meaning you're allowed to take sample sample from the pool of population without any replacement. That's why we'll use a hypergeometric formula to solve this problem. Let's start with defining the variables. Defective part drawn x. We'll assign this as 0. We assign this 0 because we are talking about a test scenario where if the tester finds even one defective part, he will reject the shipment. Now next we decide another variable, defective part in shipment, which is M. We are asked that what is the probability that manufacturer accepts unacceptable shipment? When does shipment becomes unacceptable? When it has more than 5 defective parts, right? Because of this, we will assign value as 6 because we want to make the shipment unacceptable. If there are 6 defective parts out of 100, then number of good defective parts must be 94. Good parts must be 94. The tester takes out a K sample, a K number of sample from the 100 shipment. Just for our sake, we'll give it some initial value for this, which we'll refine as we go on. Let's give 10 for now. Since being this hypergeometric distribution, meaning there is no replacement. Once you draw out a sample, there is no replacement. Because of which, we have to assume that it's a hypergeometric distribution and use the formula as such. We'll use distribution hyper formula where first item is defective parts drawn from which is X, defective part in shipment which is M, defective parts and good parts in shipment which is N, a number of samples K. Let's run this. We got 52%. This is still high. Let's see what if we increase the number of our samples. Let's do 20. What happens then? It has decreased. The percentage has decreased. As soon as we increase our number of our samples we take, the percentage that we accept the unacceptable sample has decreased. What if we increase to 30%, 30 samples? We are around 11%. What if we increase that to 35 samples? What happens then? We're getting closer, that's for sure. It is 70%. What if we do 32 samples? It has to be less than 10%, right? Therefore, this is less than 10%. What if we do 31, 10%? We want probability less than 10%. That means if the sample is at least size of 32, then the probability of accepting an unacceptable shipment is less than 10%. Therefore, the answer is 32 for this. Therefore, K is equal to 32. Next question is, now suppose the manufacturer decides to accept the shipment if there is at most one defective part in a sample. If there are two defective parts, they won't accept the shipment. How large does K have to be to ensure the probability that manufacturer accept an unacceptable shipment is less than 10%? As above, shipment is unacceptable if there are more than 5 defective parts. Let's reuse some information we already typed from the previous question. Here we need to use CDF, cumulative distribution function, and cumulative distribution function ranges from 0 to 1 defective part. And we want to see what is the percentage, how many, and 0 to 1, at 1 it has to be less than 10%, and we have to find a corresponding sample drawn K for that particular point. Defective part drawn X has to be defective part drawn X has to be 1 because that's the maximum we can draw. Defective part in a shipment has to be 6, and good part in shipment has to be 94 as we have. Sample drawn, let's do 10 for now. First thing first, we'll run this and see what we get. This is a probability of getting one drawing one defective part from a sample. This is good. Now second part is we need to find a quantile of this. The quantile, how do we find a quantile of this? We need to still add these variables here to make it work. We have hyper, this will provide the probability, and for that particular probability, what's the quantile? We'll find a corresponding quantile for that. It says defective part on shipment not found. We need to do this. We need to make some corrections in our spelling. Sample drawn key not found. Sample drawn key not found. We need to make some corrections here as well. Zero. The quantile is zero for this one, which is fine. Now, next step is to find the CDF. What is the CDF for this? The probability distribution for zero value in in the in the in the Z table. We'll use same information. We'll use this quantile to do further processing. That is, we'll let's see what happens if we do this. Must give me some error. Now what he's saying is that if we have at most one defective part and we draw 10 samples from the 100, we do 10 sample, and from the 10 sample we have at most one defective part, then probability of accepting the defective shipment is 52%. This 52% will decrease as soon as we start taking more sample. Let's do 30 here. 41%. We want this CDF to be around 10% or less than 10%. Therefore, we need to still increase our sample size. How about 50? What happens then? It is around 11%. What if we do 51? 93%. Therefore, the answer is 51 to get at most 10% probability of getting or accepting a defective shipment. That's why we'll put 951 here. K is equal to 51. Let me quickly summarize what we discussed today. We discussed about hypergeometric regression and discussed about accepting a shipment where we don't accept any shipment that has more than 5 defective parts, and if you took a sample of that, if you take a sample of that shipment, if there's one part is defective, then we won't accept a sample. And we look at the probability of accepting a defective sample with that criteria. Secondly, we change the criteria and said that if we'll accept the shipment if there is at least one defective part when take the sample, and we look at the probability of accepting a shipment with more than 5 defective parts, or let's say six defective part, and we calculated what's the sample size for that. That's all for today. I will see you in our next learning session. Thank you so much.